Hello everyone. So in today's chapter I am going to talk about crystal structure, cubic system and relationship between molar mass and density of the substance along with the relation between the molar mass, density and unit cell edge length. Let's start. Crystal structure. Crystal structure is the ordered three-dimensional arrangement of particle in the crystal, and we used to describe any crystal by using two terms, that is lattice and basis. Lattice is a geometrical arrangement of points in a three-dimensional periodic array. A crystal structure is obtained by attaching the constituent particle to each of the lattice point, and such constituent particles are attached to the lattice points. They used to form a crystal lattice. Crystal lattice is also be called as space lattice of crystal, and the crystal is the structure that results by attaching bases to each of the lattice point. You can say one crystal structure is just like a building where there are so many rooms with so many floors, and there is no space in between the 2 3 4 rooms. They are perfectly attached with each other, they are sharing the walls, and the corner of the room would be called as lattice point, where you can say the particles are there in the form of bricks, and these particles could be atoms, molecules or ions also. Now, unit cell. Now, what do you mean by unit cell? Unit cell, the space lattice of crystal, is built up by three-dimensional basic pattern. For example, if you are seeing, if this is a building, the red color part of this building, if you are assuming this is one room, there are so many rooms you are seeing here in this building. So one room is called as unit cell, and in different unit cell there is a different arrangement of particle. They may be at the corners, they may be on the face of the cube, and they may be on the inside the body of the cubical structure. So I can say unit cell is the smallest repeating structural unit of a crystalline solid, and when the unit cells are stacked together to generate a crystal, each unit cell will share its face, its edge and its corner also with a neighboring unit cell. If the crystal has cubic shape, the unit cell will also have its constituent particles arranged in the form of tiny cubes. And the dimension of unit cell along with the three axes are denoted by symbols like A, B, C, you are seeing in the diagram, and the angle between these axes are represented by alpha, beta and gamma. These all are the unit cell parameters. Now, types of unit cell. There are four types of unit cell. Unit cell number one is simple unit cell or primitive unit cell. In primitive unit cell, the constituent particles are present at the corner of the cube. Like you are seeing this one unit cell, it is cubical. There are 8 corners, and on 8 corners there are 8 particles. Only at the corner of the unit cell, if the particles are present, then such unit cells are called as simple unit cell or SC or primitive cell. Another type is BCC or body centered. In body centered, what will happen? There is a unit cell, or you can say one kind of cube, where you will see 8 corners. On 8 corners you will be seeing 8 particles, and inside the body of one cube or one unit cell you will get to see one particle. Now here I want to tell you everyone the particles which are present at the corner of the unit cell or at the lattice point. These particles used to be shared by another unit cell also, and I can say this particle, the particles which are present at the corner, these particles would not solely belong to one unit cell. They can be belong to so many other unit cells also. But in case of BCC, the particle which is present inside the particle inside this unit cell, like this particle is totally belong to this unit cell only. That is why it is called as BCC. Another unit cell is FCC or face centered. In face centered unit cell, you will get to see there are 8 particles present at the 8 corners of the cube, used to be shared by another unit cells also, and on each face of the cube you would see there is one particles present. There are 6 faces of one cube. On 6 faces 6 particles are present, and the particle which is present on one face used to be shared by 2 unit cell. The contribution of one particle toward the one unit cell present on one face is 50%. Base centered unit cell. The unit cell consists of particle at the center of any two of opposite faces in addition to the corner particles. This is all about your base centered. Now, next is crystal system. By mathematical analysis, it was proved that only 14 different kinds of space lattices are possible. And I can say that these 4 lattices which describe the crystal nature or crystal structure are called as Bravais lattices. 14 Bravais lattices are divided into 7 crystal systems, and the possible combination of lattice points on the basis of 3 axes which are A, B and C, and the angle between the axes which is alpha, beta, gamma has been done to give you 7 crystal system. And the 7 crystal systems are cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic and hexagonal system. Now let's talk about crystal system. Just now I told you these are the 7 crystal system, and you will get to see there are 3 type of cubic, there are 4 type of orthorhombic, there are 2 type of tetragonal, there are 2 type of monoclinic, and so on the basis of their axis length and the angle between the axes. Now, cubic system. Cubic system, there are 3 kinds of unit cell. Just now I told you about primitive or simple cubic. Second is body center, and third is face center. Simple cubic, the particles are only present at the 8 corners of the cube and used to be shared by different unit cells. In body centered, the particles are present at the corner of the unit cell, as well as one additional particle is present at the center of the cube. And face centered or FCC, the 8 particles are present at the corner of the cube, plus 6 particles would be present at the face of the cube. Now, number of particles in cubic unit cell. Let's talk about simple cubic first. A simple cubic cell has particles at its 8 corners only. When these unit cells are stacked together, the particles at each corner of a given unit is shared with another 7 unit cells or another 7 neighboring unit cells or another 7 cubes in easy language. So So I can say the corner particle, the particle which is present at the corner, contributes its 1 upon 8 part to the unit cell. And if one particle is contributing only its 1 upon 8th part, and there are total 8 particles present at the 8 corners of the unit cell, so the contribution of total 8 particles present at the corner would be 1 upon 8 multiplied by 8, which is 1 particle per unit cell. In body centered, what will happen? There are 8 corners and 1 particle will contribute its 1 upon 8 part towards the 1 unit cell. So from 8 corners we will be getting 1 particle plus. In BCC, there is 1 additional particle present inside the body of the unit cell. So 1 particle from the corners plus 1 particle inside the body. So there are 2 particles per BCC unit cell. Now FCC, face centered unit cell. A face centered unit cell has particles at 8 corners. Their contribution is 1 upon 8 per particle. So from corners we will be getting 1 particle in a unit cell plus each cube has 6 faces and each face particle, the particle which is present on face, contributed its 1 upon 2 part to 1 unit cell. So there are 6 faces, so 1 upon 2 multiplied by 6 will be getting 3 particles from the face plus 1 particle from the corners. So in case of FCC, we got 4 particles from 1 unit cell. Now, relationship between the molar mass density of the substances, and it used to be deduced in this way. You all know the edge length we are representing by A. Its volume would be A cube. Volume of any cube is equal to cube of its edge length. So A cube is the volume of unit cell. If one particle mass is m, there are n particles, so total mass of unit cell would be m multiplied by n. Density, we all know, it is equal to mass of unit cell upon volume of unit cell. So the mass of a unit cell is m multiplied by n, which we have written here, upon A cube would be the volume of unit cell. And we all know molar mass is equal to mass of one particle multiplied by the number of particles, or we can say m multiplied by Avogadro constant. And we can say mass is equal to molar mass upon Avogadro constant. So combining this equation 1.1 and 1.3, we'll be getting density rho is equal to Nm upon A cube multiplied by Na. So this is the formula which you are going to use in solving numericals. Thank you.